Hello students, welcome back to today's class on triangles. Triangles is a very basic concept of geometry, and from triangle we are going to discuss a lot of properties which again will be useful for dealing with the other shapes like quadrilaterals and other geometrical figures. Right, my name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So first of all, let us try to see what is a triangle. What are we discussing about a triangle, right? So triangle, is it a three-sided polygon? So some person is thinking she's thinking that is a triangle a three-sided polygon. I told you in the last class as a polygon is a closed figure. Polygon is a closed figure with all the line segments, right? So is it a three-sided polygon? Triangle has three angles. Triangle has three sides. Triangle has three angles. So are these all correct? So let's try to discuss what is a triangle first of all. Okay, triangle is a closed three-sided figure. Closed three-sided figure formed by only line segments. So it is a polygon, right? Therefore, it is said as three-sided polygon. And triangle is the first polygon. First polygon in the sense you cannot have polygon with the two sides. You cannot have polygon with one side. Polygon is always closed. So for closed, you need to have at least three line segments like this. 1, 2, 3. So in that, the the first polygon we can say is a triangle with a three-sided. We cannot have two-sided triangle. In this chapter, we will look into topics like congruence of triangles and few properties of triangles. Okay. So congruence, what do you mean by congruence? We're going to discuss that. We can say similar type of triangles. Right, if you have two triangles of the same shape or same angles or same length of sides with some properties, then we say they are congruent. Congruence of triangles. Okay, so let's move forward to learn all this. When are two figures congruent? When are two figures congruent? You can see here two figures are said to be congruent if they are same in shape and size. If they are in same shape and size. That means they should have same shape as well as size. Size in the sense, all the measurements. One side measurement is 4, 5, 6, let's say. One triangle is having 4, 5, 6 as the side lengths. Okay, let's say. So other triangle will be having 5, 4, 6. Okay, this is 6, 6, 4 and 5. So now tell me, are these two similar triangles, or we say, are these two triangles congruent? Yes. This 4 and 4, 5 and 5, 6 and 6, just orientation is different. The rotation is different, but the thing is, they have the same shape and size. So we can say that these type of triangles are congruent. These type of triangles are congruent, okay? Two line segments are congruent if they are of equal length. If they are of equal length, two lengths, okay, two lines are congruent if they are of equal length. Let's say I have 5 centimeter line here and 5 centimeter line here, let's say. So now my question is, are these two congruent? And we say yes. Why? They're having same shape and same size irrespective of their position. They can be placed anywhere. That 5 centimeters can be here, can be here, can be here, wherever it is. The point is they should have the same shape and same size. Shape is a straight line and size is 5 centimeters for both of them. So we can say that these two are congruent. Okay. So these two lines are congruent. You can say, let's say this is 10 centimeters, even this is also 10 centimeters. So we can say these two are congruent. Two angles are congruent if their angle measure is same. You know what is an angle, right? That formed by two rays. Two rays starting from one starting point, which we call vertex, right? So this measurement, whatever we measure here, is angle. That measurement is angle, right? So that measurement is angle. So we can say that, let's say this is 30 degrees. Even if you don't know what is degrees, what is 30, 40, 50, whatever it is, okay? But if this is 30 and even this is 30, if both are in the same shape, same size and having the same measurement. For sides we talk about same size and same shape, but for angles we say that measurement should be same. that measurement of angle should be same, then we can say that the angles are congruent. So now you can ask me, sir, why are we discussing all this? Why are we saying congruent in length, congruent in angles? Because to discuss about congruence of triangles, how to say whether two triangles are congruent or not, we need to go with congruence of sides as well as congruence of angles. Once we can relate two triangles with congruence of sides or angles, then we can say these two triangles are congruent. These two triangles are congruent. Okay, so let's see. Two squares can be congruent if the sides are equal. The sides are equal. Okay, so these two squares, this is 5 centimeters in length, even this is in 5 centimeters, so we can say that these two are congruent. We don't say equal. Okay, when we are having two different figures, generally we don't say equal, we say congruent. Two squares can be congruent if the sides are equal. If two squares are congruent, their diagonals are also equal. So this is 5 centimeters, this is 5 centimeters, right? So whatever the diagonal length will be, generally it will be of length of 5 root 2 centimeters. Okay, so even the diagonal of the other square will also be equal to 5 root 2 centimeters. Again, diagonals will also be or of equal length in congruent figures. Okay, congruent, when I am saying everything is same to same here, the side length is same, diagonal length is same, so angles will be same. So in that case everything will be same, but we don't use the name same, we don't use the word same. For geometrical figures we use the name congruent, we use the name congruent. Understand? Okay, so let's move forward. Corresponding parts of congruent triangles are equal. What do you mean by that? We often use a CPCT. We often use a CPCT in many of the derivations or proofs or whatever we're going to discuss today. We use sometimes CPCT directly without writing all these always. So what does this property says that? Corresponding parts. What do you mean by parts? What do you mean by corresponding parts? Parts means what parts will triangle have? It can have sides, it can have angles, right? Or any other thing, whatever we discuss for the triangles. Two triangles, if they're congruent, their parts, that means the sides as well as angles, will also be equal. Okay, so corresponding parts of congruent triangles are equal. We say it is a CPCT. So let's try to discuss one or two applications based on this CPCT. CPCT, corresponding parts of corresponding triangles will be equal. So the first one we're going to discuss about the congruence is SSS congruence. Side, side, side. That means for two triangles, all the three sides of the first triangle will be the same or will be equal to the three sides of the other triangle. However, maybe their orientation or their position, but if they're having three equal sides, we can say that SSS congruence will be applied, and we can say that those two triangles are congruent. In the same way, we have SAS congruence, side angle side congruence. Here it is SSS, side side side. Here it is a side angle side. The next one is ASA, angle side angle. For two triangles, if angle side angle, angle side angle are equal, we can say that those two triangles are congruent. And same way, we have AAS congruence, angle angle side, angle angle side. And you can ask me one question, sir, why not AAA, angle angle A angle? So when all the three sides are equal, we say for two triangles, even angles will also be the same for those two triangles. That is the reason you discuss about SSS, but we don't discuss about AAA, but both are same, side side side, or angle angle angle, both are same. Right, so moving forward, let's try to understand what is the SSS congruency. So all the three sides, that is very important, side side side. If two triangles, if the three sides of one triangle, okay, are respectively equal to the corresponding three sides of another triangle. Are correspondingly equal to the corresponding three sides of another triangle. What do you mean by this corresponding? I'll tell you. Okay. Then the two triangles are congruent. This is the first congruence we're talking about. S, 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 side, 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 all the three sides. All the three sides. Okay, so we have three sides here. In two triangles, if the three sides of one triangle are respectively equal to the corresponding three sides of another triangle. For example, if this is 4, 5, and let's say this is 6 centimeters. Okay, it may or may not be possible, but just in case. In the same way, if you have 4, 5, 6. Now carefully observe these two triangles. All the sides are equal, corresponding. What do you mean by corresponding? This side and this side are equal. This side and this side is equal. 5 and 5. Let me write ABC. ABC and PQR. ABC and PQR. If I say ABC and PQR are congruent, okay, we say like this. Triangle, we represent triangle. Triangle ABC is congruent to, so this is the symbol we use. This is the symbol used for congruency. Okay, so triangle ABC is congruent to triangle PQR, and when we are writing like this, the order of the alphabets is very, very important. A should be corresponding to P, B should be corresponding to Q, C with R. That means the shapes should be in alignment. The shape should be in alignment. The way you write A, the way you write the first one P, these two should be in the same positions. See, A is a point here with the 4 centimeters and 6 centimeters side intersection. The same 4 and 6 will intersect at P, correct? But you cannot change like this. Triangle ABC is congruent to triangle QRP. Let us say QRP. No, that is wrong. These two are wrong because A and Q are not the corresponding things. A and Q, A is here, Q is here, not the corresponding things. So we cannot say like this. So this notation is correct. Corresponding side to side should be equal. Right. So let's try to discuss one more example for this triplex congruency. For example, I have two triangles. Let me say this is 4 centimeters, 5 centimeters, and 6 centimeters. The same example I'm taking. And let's say now it is a 4, 5, 6. This is a triangle ABC and a triangle PQR. So now, can I say triangle ABC is congruent to triangle PQR? Can we say like this? We cannot say triangle ABC and PQR are congruent. We cannot say ABC and PQR are congruent. Okay, so now see here. This is AB. AB is a 4 centimeters, but not PQ. AB and PQ, these two are not the same. These two are not the same, correct? But AB is equal to QR. AB is equal to QR. Okay. BC is equal to PQ. And CA is equal to PR. That means we need to change our orientation. We need to change our representation. We cannot say ABC and PQ. The corresponding sides or corresponding vertices are not mapped properly between these two congruent triangles. As all the sides are equal, we can say yes, these are congruent, but the way of representation is very important. So A4 and then 5 and then 6. ABC, triangle ABC is congruent to 4, 5, 6, 4, 5, 6. So RQP, triangle RQP. So you might ask me, sir, how are we writing like this? Why are we changing? So you can simply come up with the side lengths. You can simply come up with side lengths. So 4 and then 5 and then 6. AB is 4, BC is 6. Sorry, AB is 4, BC is 5. The same way, RQ is 4 and QP is 5. So 4, 5 and 4, 5. So that is how you can say that these two triangles are congruent. Triangle ABC is congruent to triangle RQP. Congruency. Congruent, same shape or same orientation, same shape and same size. Here S. Side should be equal. But the way of representation is also very important, right? So let's move forward for the next one. If two triangles congruent, then their corresponding angles are equal. So this is the point I'm saying before. If two triangles are congruent, then the corresponding angles are equal. For example, I say triangle ABC and triangle PQR. These two are congruent. If I say triangle ABC is congruent to triangle PQR, so what I can say here, the corresponding angles, that means angle A and angle P are equal. Angle B and angle Q are equal. Angle C and angle R are also equal. So we discuss about SSS, but inside that we also have one more congruency, AAA congruence. That means if all the three sides are equal, the corresponding all the three angles of both the congruent triangles will also be equal. Right. Moving ahead. So we have a question here. Let's try to understand that. In a quadrilateral ABCD, so AB is equal to CD. AB is equal to CD. Okay, so this and this are equal. BC is equal to AD. BC is equal to AD. Okay, good. Show that triangle ABC is congruent to triangle CDA. So now carefully observe. AB is congruent, or AB is equal to CD, it was given. BC is given as AD. Now the next one, in this triangle ABC, the other side left is AC. The same way in the triangle ADC or CDA, whatever it is, angle ADC, the other side left is AC. These two are equal in triangle ABC and triangle ADC. AC is equal to AC because it is a common side, that is a side for both the triangles. Okay, so because this is a common side, this is a common side, right? So we can say that now using SSS, using side congruence, triple S congruence, we can say these two triangles are congruent. Which two? Not these two. Triangle ABC triangle ABC is congruent to triangle CDA. Triangle ABC is congruent to CDA. AB, the very first length, is as equal as CD. So AB and CD should be equal. In the same way, wherever you have BC, you should have DA. BC and DA should be equal. Right? So that is how you can try to find the two figures are congruent using SSS congruency. Side congruency. Right? So moving ahead, from the given figure, show that the line PQ is a perpendicular bisector of AB. From the given figure, show that the line PQ, from the given figure, show that the line PQ, where is PQ? PQ, okay, is a perpendicular bisector of AB. So what do you mean by perpendicular bisector? What do you mean by perpendicular bisector? So let me explain you. For example, we have A here and B here. So the line which is perpendicular to this line and bisecting means dividing into two parts. Bisecting means dividing into two parts. Okay, so dividing into two parts. So this type of a line, the line which is perpendicular and dividing into two parts, we say it is a perpendicular bisector. We say it is a perpendicular bisector. So now we need to apply so many relations here, so many congruence relations or whatever it is to understand how to say that these two triangles, these two things are, these two, I mean to say how to show that it is a perpendicular bisector of AB. But once again, let's try to come back to this question after discussing one more congruency, because here we should also show that this angle is 90 degrees. That means we should also have a congruency that is related to angles. Till now we haven't discussed that. We just discussed SSS, triple S congruency. We didn't discuss about any angle. So once again, after discussing some congruence of angles, let's come back to this question. Okay, so what's the next question we are having? What is the next property we are having? SAS congruency. Okay, SAS congruency. So what is this? two triangles are congruent if two sides and included angle, and A is included angle, okay, and the included angle. What do you mean by included angle? I'll tell you using the figure of one triangle are equal to the two sides and the included angle of another triangle, then we can say that as per SAS congruency, those two triangles are congruent. As per SAS congruency, those two triangles are congruent, okay. So this is about A, B and C. Let's say this is ABC, and let's say this is a PQR. Let's say this is a PQR, ABC and PQR. Okay, two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of another triangle. So let's say this side and this side are equal. AB and PQ are equal. Let me write one more. Let me write one more side because it is SAS. BC, let's say it is equal to PR. Okay, it is very simple to relate BC and QR, but let's try to understand in a different approach. Let's say that as that side is equal to PR. Okay, just for our reference. Now, what is the corresponding angle? Corresponding angle is this one. So B and here P. B and P, if these two are equal, SAS, not any other side, not any other side. It is not at any other angle, it is the angle included with those two sides. Okay, so then we can say that these two are congruent triangles using the relation SAS congruency. Using SAS congruent, we can say that these two are congruent. Okay, so now what I can say, AB is equal to PQ. Okay, good. BC is equal to PR. So you should be very careful now. The orientations are different. Okay. And angle B is equal to angle P. Angle B is equal to angle P. Okay. So if I talk about triangle ABC, so AB is PQ. Okay. But what is B? B is P. P is as similar as B. So in place of B, keep P. Now, in place of B, if I keep P, what is A? A is Q. In the place of B, if I keep P, the corresponding point of A is Q. So I can say that QPR, triangle ABC is as similar as triangle QPR. Because the first one is AB here, which should be equal to PQ or QP. PQ or QP are same, that is equal. The next part is a BC. The next part is BC, which should be equal to PR. Yes, it is a PR, right? So you cannot change the order, and if you're changing the order, we cannot say that these two triangles are congruent. So we have discussed SAS congruency and AAA congruency. SAS congruency. So now let's come back to the same question which we are left with in the last class. So from the figure, from the before slide, from the given figure, show that the line PQ is the perpendicular bisector of AB. So we need to apply the properties whatever we know till now. Okay, so let me try to bring some relation between different triangles. Okay, so let me discuss about triangle APB and triangle ABQ or angle AQB. Triangle AQB. So can we bring any relations here? Okay, if not what we can say, as these two sides are equal, I'll talk about APQ and BPQ. I think that will be easy. Okay, instead of those triangles, as we have, see, this line states that this one and this one are equal, and these two sides are equal. Okay, so let me talk about triangle PAQ and triangle PBQ. Triangle PAQ and triangle PBQ. Okay, not angle, it is a triangle. So what I can say here, when I want to see the values, we need to compare AP and PB. We need to compare AQ and BQ, and using these two sides, You can also see one more thing. PQ is a common side. PQ is the common side. This side is equal to this one. This side is equal to this one. And the common side is equal to for both of them. So using S congruency, we can say these two triangles are congruent. But that's not sufficient. Using more applications and more congruency here, you need to understand that this line which is PQ is perpendicular bisector. That means you need to prove few things, which I'm giving you as a take-home task that we are going to discuss in the next class. Okay, the perpendicular bisector of AB. So this angle and this angle, these two should be 90 degrees. Okay, and the complete thing we can show that it is a 180 degrees, and as it is a perpendicular bisector, you should also prove that these two sides are equal. So this you need to prove using different congruencies that we have learned in this class, right? So the next class we are going to start our discussion with how to prove this as a perpendicular bisector, right? So and after that we have a couple of more questions, and also we have a couple of more congruencies which we are going to cover in the next class, right? So we have ASA congruency, ASA angle side angle, okay, angle side angle. We discussed SSS, okay, which is also something like AAA, and we also discussed SAS. In the next class, let's try to discuss about ASA angle side angle, right? So these are very interesting and very creative applications will be applied here. So please focus on every congruency and don't confuse with one congruency with the other, right? So I hope you understood this one. So thank you so much. Stay tuned to get the next lecture. Thank you.
Hello everyone. So today again we will be discussing about Newton's third law of motion. That is the reason why part 2. Okay. So my name is Seshan Reddy. I am a graduate from IIT Dhanbad. Let's go into the class. So let us first revise whatever we have learned regarding Newton's third law. Right. So what is the statement for Newton's third law? For every action there is an equal and opposite reaction. The mathematical expression is F12 is equal to minus F21. What does F12 mean? I told you, first comes on, second comes by. Yes or no? First comes on, then comes by. So it is force on 1 by 2. F12 will mean force on 1 by 2. And what does minus mean here? Minus shows opposite direction. That is, action and reaction are in opposite directions. And F21 will mean force on 2 by 1. Got it? So all the points are discussed. So this is a mathematical expression which is important. Equal and opposite. Clear? Good. And then we learned a few points regarding Newton's third law of motion. What are they? One is action and reaction are forces, basic. Action and reaction are opposite in direction. Action and reaction are equal in terms of magnitude. Action and reaction act on two different bodies. Very, very, very important. They act on two different bodies. If one force acts on object 1, the other force will act on object 2. Okay, two different bodies. Then you have this, they occur simultaneously. Simultaneously will mean at the same time. Right, there is no time lag between the forces. And no third body is involved. You always start with identifying the bodies. And how many bodies will be there? Only two. Two bodies, and then you go into action and reaction. That's it. No third body. Okay. Good. So these are some points that we have learned. Very interesting points. Yes. So I'll go into a few examples to understand it better. Okay. So we have one here. It's an interesting one, right? Interesting animation, right? Okay. He appears angry, very angry. But yeah, coming back to the question, if you punch a wall with 20 Newton of force, what force does the wall exert on you? That's an interesting question. If you are punching a wall with a force of 20 Newton, what force does the wall exert on you? Yes, everyone? What will it be? That's again Newton's third law. If you understand Newton's third law, you can easily say, or you can easily answer this. So what is this going to be? Yeah? And the answer is 20 newtons itself. The answer is how much? 20 newtons itself. Got it? Now, why? Because it's very simple. Action and reaction are equal and opposite. Opposite is for direction. Equal is for magnitude. So if F12 is equal to 20 Newton and F21 will be equal to 20 Newton. You can just say minus 20 Newton. Minus for opposite direction. That's it. That means if you have a wall and if you have a person hitting a ball, then what are the forces acting? One force will be force on the wall by the person. And the other force, obviously the reaction will be force on the person by the wall. They are opposite and they will be equal. So if one is equal to 20 Newton, the other one will also be 20 Newton. This is force on the person by the wall. So if you read the question, what force does the wall exert on you? Does the wall apply on you? How much force is the wall applying on you or on the person? 20 Newton. And that is the answer. Simple. Action and reaction are equal. Good? Simple? Yes. Let's continue. Next. Why does a boat move backward when we step out of it? Why does a boat move backward when we step out of it? So imagine this. The case is this. This is, let's say, a boat. Okay. And there is a person who is just stepping out of it. He is going in this way. Okay, stepping out. Then the boat moves backward. Now, why is this happening or why does this happen? Yeah, everyone, why does this happen? And it's something which actually happens in real life. Right? It actually happens. Now, the question is, why? Because we can explain everything in terms of force. So, what is happening here? Think about that, everyone. I'll give you 1 minute of time. 1 minute of time. So, please think about this. In fact, write down a proper answer. And then, after 1 minute, you can compare your answer with mine. So, what is that going to be? Write it down. Write the answer down properly. Write it down. So 30 seconds more. Ten seconds more. 3, 2, 1. The time is up. Now why? It's very simple. Look at the diagram. The diagram itself will take care. Now everything can be explained using Newton's third law. At least this can be explained. So what are the two bodies here? Two bodies. The first step is identifying the two bodies. You can say the person and the boat. Right, now imagine when you are walking, how do you apply the force? You can walk and see. When you are walking, how do you apply the force? You push the ground back. We push the ground back, yes or no? So here when the person has to step out of it, has to come out of it, he will apply a force. He'll apply a force on the boat. So FBP. So what is FBP? Force on the boat by the person backwards. And obviously the boat applies a force on the person forward. And that is the reason when we walk, we apply a force backward, right? The same way here the person applies a force backward on the boat and then he walks. Right? The boat pushes him forward and he pushes the boat backward. Okay, so here you identified the two forces. What are the two forces, everyone? The two forces are, what are the two forces acting? FBP. Force, first comes on, force on boat by person. In which direction it will be? Backwards. On the boat, the force is backwards. And the second force is FPB, which is force on person by boat. Now in which direction will this be? Opposite. So it will be forward. So on the person, the force acting is forward. That is the reason why the person moves forward. That is the reason why we move forward. But on the boat, you are applying a backward force and the boat moves backward. So you can say a person applies a backward force. A backward force on the boat. A backward force on the boat, and the boat moves back. Simple, that's it. That is the reason why the boat moves backward. We have given the reasons. Everything comes from Newton's third law. Identify the two forces, their direction, and that's it. It is done. This is forward direction, and this is backward. Got it? Clear? Good, good, good. Let's continue now. Next question. State the action and reaction when a person walks on a floor. I think we almost discussed that now. So you tell me what are the action and reaction. I'll again give you 1 minute of time. So please solve it. 1 minute of time, everyone. Write it down. Do not just do it in a year. Write it down properly. You have 30 seconds more. You have 30 seconds more. Write down a proper answer. Yeah, 15 seconds more. So 3, 2, 1, and the time is up. So here, when you walk, or when anyone walks, when any person walks, he applies a force in the backward direction. Okay, you can write this down. When we walk, we apply a force on the floor, or you can say the ground, a force on the floor in the backward direction. In the backward direction. Right, we push the floor back. And then you can have to write according to Newton's third law. According to Newton's third law. Writing it down will make your answer appear good. Right, writing down the reason, writing down the law used. We are using Newton's third law. So mention according to Newton's third law. For every action there is an equal and opposite reaction, that's fine. According to Newton's third law, the floor also applies a force, but on whom? Force, or the floor also applies a force on the person in the opposite direction. But what is opposite here? First force is backward, the other force will be what? Forward. In the forward direction. Is that clear? So that's it. And because of this force, the person or we will move back. We will move forward. Because the floor is pushing us forward, we move forward. You can see the image, everyone. So when we walk, foot's thrust against the ground, foot's force against the ground. And here, then you can see another force acting, which is ground's thrust against us. So we push the floor back or we push the ground back and the ground pushes us forward. Is that clear? Yes? Good. Next. Now this is a very important question, very important question. So understand this. When pushing an object, if the action and reaction are equal and opposite, they should cancel each other and the object should not move. So how do objects move? See, on the object there are two forces here, yes or no? When there are two forces, action and reaction. But the action and reaction are equal and opposite. So if there are two forces equal and opposite, they should cancel each other. If one is 10 Newton, the other is also 10 Newton. So net force should be 0. If net force is 0, the body should not move, the object should not move, or the box should not move. But it moves. Why? Are we making any mistake? If there is any mistake, then please let us know. What is the reason? Why don't they cancel each other out? Why is the box moving if the action and reaction cancel each other out? 1 minute of time, so solve it. Write down the answer properly. Writing it down is presenting it. Writing is presenting. See, everyone, when you go out, when you go to any function, you wear proper clothes. Yes or no? You want to appear good. Yes. The same way answer writing is also an art. Your answer should appear good, so that your presentation will be good. That's an art. Develop it. Okay. 20 seconds more. Whether you write an answer, whether you tell an answer to someone or anything else, your presentation should be good. Okay. So write it down. 5 seconds more. And the time is up. So why don't the forces cancel each other out? So first of all, let us first identify the forces in this case. Let us do that. The steps. Identify the two bodies. The two bodies are the boy and box. There is an issue. Why when I say boy and box? Boy and boy. Boy and box. B and B. Right? So I'll say kid and box. There is a kid and there is a box. Okay, the two bodies are what? The kid and the box. Now what are the two forces then? The two forces will be, one is FBK. What is FBK? First comes on, second comes by. Force on book by kid. Force on book by kid. Simple. Then again another force. Just change the order. FKB. Force on kid by book. Not book, right? By box. My mistake. It should be box, not book. It should be box. Okay. So you got the two forces. Now how will the two forces be? Thing is, when I separate them, if I draw them separately, consider them separately, then on the box, there is one force acting, force on the box by the kid. And the other force is acting on what? Is acting on the kid, force on kid by the box. That means you can clearly see the two forces, action and reaction, are acting on two different bodies. Now if I look only at the box, And if I look at the forces acting on it, there is only one force acting on the box. And if there is only one force acting on the box will move. Yes or no? Right. So what is the main reason? The main reason is the question itself is wrong. The reasoning is wrong. According to the question, action and reaction are equal and opposite. Okay, they should cancel each other, but that is wrong. They do not cancel each other. Why don't they cancel each other? Because they are acting on two different bodies. I told you that is one very important point. Action and reaction act on two different bodies. Action and reaction act on two different objects. Act on two different objects. And hence they do not cancel each other. Hence they do not cancel each other. That's it. So when you talk about the box, you talk about forces acting on the box. On the box there is only one force. That is the reason why the box will start moving. Clear? Good enough? Simple? That's wonderful. Let's continue. Next question. Why don't action and reaction cancel each other? The same thing that we discussed. On a given object, let's say if I consider the box, only one of the action and reaction act, not both of them, only one of them acts, as we discussed. On the box, only the force by the boy acts and the reaction acts on the boy. One force is on the box and the other force is on the boy. Two different objects. Okay. So considering the box, only one force acts and it moves. Whatever we have discussed. Right. So what is the main reason? The point I told you, this point is very important. Action and reaction act on two different objects or on two different bodies. Clear? Good. So that was discussed. Now next question. And again it's a very important question. Interesting too. Does Newton's third law apply for non-contact forces? What are non-contact forces? Some examples. Gravitational force, electrostatic force, magnetic force. So let's say, assume that these two are magnets. Assume these two are magnets. They are not touching each other. Right? They are not touching each other. Now in this case, is Newton's third law applicable? Is Newton's third law applicable in this case? Interesting question, right? That is Newton's third law applicable for gravitational force, for electrostatic force, for magnetic force? Is that applicable? I think for gravitational force we did discuss that point. Not explicitly, but we went into an example. So that should give you the answer. So what is the answer? Yes or no? Does Newton's third law apply for non-contact forces? Yes or no? And the correct answer is yes, it is applicable for every force. For it could be contact forces like friction, like normal force, like tension, like spring force, doesn't matter. It is applicable there. It could be non-contact forces like gravitational, magnetic, electrostatic, doesn't matter. Newton's third law is applicable everywhere, for every force. That is the beauty of Newton's third law. Law will mean rule. Rule will mean followed all the time. Okay? Good? Wonderful. Chalo. Next question. Can a bird, right? Yeah. Can a bird fly in space? Explain. First of all, we'll go into the question. Can a bird fly in space? Yes or no? What do you think? Again, I'll give you 1 minute of time. Write down the complete answer. And then you can compare your answer with mine. So 1 minute everyone. Please solve it. Can a bird fly in space? That's an interesting question, right? Imagine, obviously you can never find a bird in space. But if at all, if you take a bird to space, can it fly there? Yes or no? By itself. Don't say I'll apply jets and all to it. No. By itself, can a bird fly in space? Explain. Yeah. Can a bird fly in space? Yes or no? Yeah, everyone? So 3, 2, 1, the time is up. And the answer is no. But the reason, what is the reason? It's very simple. Normally in atmosphere or in air, how does the bird fly? Obviously it flaps its wings. But what does it do? What it does is similar to how we walk, how we swim, or how fishes swim, or how a frog swims. We discussed that. In air, bird applies a backward force on air. Bird applies a backward force on air, and then air, according to Newton's third law, if bird is applying a force on air, then what happens? Air will also apply an opposite force, equal and opposite force on the bird, and air exerts or applies a forward force, opposite force. So for opposite of backward is forward, it applies a forward force on the bird, and that is the reason why bird goes forward. Who pushes it forward? Air pushes it forward. Who pushes it forward? Air pushes it forward. Now that's interesting. Okay. Now in space, who will push it forward in space? In space will mean no air. In space there is no air, there is nothing. I will just say space is empty. Space is empty. So even if you take a bird to space, it cannot push anything backward and nothing will push it forward. Yes or no? It cannot push anything backward and nothing, it cannot push anything backward, nothing will push it forward, and it cannot move. In space, or space is empty, so there is nothing in space on which the bird can apply a backward force. On which the bird can apply a backward force. Simple. So that is the reason why birds cannot fly in space. That is the reason why birds cannot fly in space. Is that clear? Right, so we have many interesting examples, right? So this way we discussed about what? Newton's third law. We discussed about some interesting points regarding action and reaction. We also discussed why action and reaction do not cancel each other out, which is a very important question. Okay, so please do practice. There are many applications. Please go through them. Write down the answers. I told you, present